Okay, so we're comparing functions again. Similar to yesterday. So today we have Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. And then we have Mr. Brown. He also bought a used car, and his monthly payment plan is shown in this table. So what we're going to do today is we're going to find the rate of change and the initial values for each of these are two different functions. How do we know their functions? Look at the table. How do we know that's a function?
What do we remember about something being a function versus something not being a function?
With the input and the output.
What about them?
You can get like, I'm trying to remember. You can take the one and get, you can't get two different outcomes.
Yeah, so for every input, there's exactly one output. Alright, so we're going to find and compare the rate of change and the initial value for each of these functions. And that's how we're going to compare the functions.
So this is just like what we did yesterday with the trees. Okay, it's a table, we used a graph, but there are some differences. So think back to what we did yesterday, because you all did great yesterday. You did well on the DOL. Keep your DOL handy, because that may help answer some of these questions. We're going to try to work on our resourcefulness.
Okay, so let's take a look at Mr. Brown first. He's our table. So he bought a used car. What's his rate of change? Or actually, let's look at what's his initial value? What's the initial value? How do you know? It's the amount he owes.
What
What else? How do we
why
know?
x0? Like, we know the initial value is 2,400. What does that mean in the scenario?
That's how much you just put down for
Yeah, that's how much the car cost. Or that's how much he paid. But did he pay it all at once? No. What's he going to do? He's going to make a monthly payment. Very realistic scenario. If you buy a car, you buy a house, you don't just walk in and pay cash all the time. Some people do. Most of the time you do like a loan, where you would pay every month a certain amount until you don't owe any more money.
So how much did he pay each month?
Rolando Velasquez to the main office. Rolando Velasquez to the main office, please. Alejandro Vargas to the main office.
How much did he pay each month?
Ray's calling her. Hey.
How do you know 300? What did you look at?
Because what's the pattern? Every month that's passing, what do you see in the table? The total amount is doing what? It's decreasing by how much? Good. So if the amount that he owes is going down by 300, what does that mean must be happening every month?
He has to pay.
He has to be paying $300. That's the only way the amount he owes. It's not like the place is going to be like, you know what, a month passed, we're just going to take some money off your bill. No, he paid $300. That's why the amount that he owes went down.
So,
Wait, hold on 1 second. Ask again.
the $2,400 is the money that he starts with?
If he what?
The $2,400 is the amount that he starts with?
It's like the amount he owes in the beginning. And then over time, because he's paying, what do we notice about the amount that he owes? Good, and then look at that total. Every month, he owes a little bit less and a little bit less. And then what's going to happen eventually? Yeah, he's going to pay it off. Exactly.
So what is our rate of change here? We're saying Brian said every month he's paying $300. What is our rate of change?
The actual number. You already saw it in the table because you see the movement. If you were told to just give the value, what is the value of our rate of change?
What is our rate of change here? So every 1 month passes, for every 1 month passes, he's paying $300. What is our rate of change?
How's that total amount changing every month?
Negative 300. Why negative? Yeah, because the amount's going down. Because that's not how much he's paying. He's not getting $300. He's paying $300 every month. Good. Now let's take a look at Mrs. White. What is her initial value? It says Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. What is her initial value?
And this has been your strength. Like yesterday's DOL, your strength was that you could read the scenario and identify. We need work on the tables and the graphs. That's where it gets a little tough.
3,000. How do you know 3,000? How did Jarek know 3,000? Why not 300? Somebody else. Gunnar. Why 3,000? Why is 3,000 our initial value? Yeah, because she started with no time has passed. So our X value in months would be 0. 0 months passed. And she owes right in the beginning for our Y value, how much she owes would be $3,000. So what is the rate of change then? What's our rate of change? What is our rate of change here?
We know she started with a debt of $3,000, and then it says she's going to make monthly payments. So how is our amount changing every month? It's decreasing by 300. What number represents a decrease of 300? Negative 300. Perfect.
100 and our initial value is 3,000.
Do you have enough information to compare these scenarios now? Yeah, because you've already identified the initial value for both and the rate of change for both. When you compare, that's really the first thing you need to do, because that'll give you a much better understanding of what's going on.
Okay, so now if we like to, when we're comparing, have everything, the two functions in the same format. It's easier to look at and to know, be able to compare, right? So we're gonna take Mrs. White's plan and put it into a table so we can easily compare Mr. Brown and Mrs. White. So how can we make Mrs. White's plan into a table?
What values can we put in? And we can go through this quick because you see the pattern very well.
3,000 and 0.
Yeah, so for 0 months, we know that she owes $3,000. What about for 1 month? How did you get that? Good. So every 1 month that passes, she's paying $300. So what about after 2 months? How much does she owe now?
2,000.
All right. After 3 months, 4 months. How much after 4 months? 1,800. 5 months. 1,000. 6 months. Every month that passes, we're subtracting $300 and how much she's paying. Okay. And for 8 months. Or 6 months. Awesome. Answer that question. Okay, so now we're going to take Mrs. White's table and make a graph. How can we start?
What direction should it be moving? Before we even graph it, what should it look like? The line. We know the initial value, we know the rate of change. So without actually plotting points on your graph, what should it look like? It should be a line going down. And where should it start? It should start higher up on the y-axis because our initial value is what? What does it represent here? What's the initial value represent in this scenario? The amount in the beginning that they owe. And over time, that total amount, based on that rate of change that you identified, is going down, which is why your line should be decreasing. When you graph, If you see all of a sudden that for some reason your line is going up, then your graph is wrong or the values on your table are represented wrong. Again, like we talked about yesterday, the common sense part comes in here. You know, they owe money, the total amount owed is going down every month. In terms of a graph, that graph should be going down as well.
Okay, so how can we set this up then? What's our x-axis going to be? What's our y-axis?
What's the first coordinate we can plot on this line?
0, 3,000.
Good, 0 and 3,000. Where would you put that? Think about what the coordinates represent. Go ahead. On the y-axis, perfect. We'll go home.
Alright, 3, 0, 3,000.
And what?
Then what?
1 and 2,000.
1 and 2,007. Do you see how for each unit on our y-axis, I'm not just doing 1, 2, 3, 4, 5, 6, 7, going all the way to 3,000. That would take all cuts, all day, right? Do you see I'm moving just by 300s? Why am I going by 300s on the y-axis?
Good, that's how much you paid every month.
Yeah, because that's the easiest way to graph our information that we have right now. Because here we're going by 300, so why not on here?
Why is the slope not -1? Because here's the thing. We learned slope, rise over run. From that first point, Miss K, to go to the next point, is going down 1 unit and over 1 unit. So is our slope -1? Does that make sense? If we know every month that Mrs. White is paying 3, and this is a connection we have to make here because some of you are doing this obviously not intentionally. We're getting very caught up on rise over run. I'm going down 1 unit and I'm going over 1 unit, so my slope must be -1. Why is the slope not -1? What is the slope?
Steep.
Hmm? Okay, but what's the value in this scenario? Which is what? So our slope is the rate of change. What's our rate of change? -300. So how is that related to the graph? Because I see that you're telling me the rate of change is -300. The rate of change is the same as the slope, which means my slope must be -300. But I'm looking at that graph and I'm seeing a slope of -1 over 1. I'm going down 1 and over 1. What's the disconnect? Why is the slope -300, but my graph is showing it as just 1? What do you think? Because every box on my graph, this is key, please look at this. Every box on the graph is represented by $300. So even though you're moving 1 box, right, 1 unit, you've actually moved $300. This is why when we label graphs, we don't always want to do like 1, 2, 3, because for so long that's how you graphed. But now you think that every unit has to be just 1. But it's not. We're going from 3,000 down to 2,700. We are going down 300. That is a key mistake that some of you made on yesterday's DOL that we need to see moving forward. It's not -1 over 1. It's actually, we moved down 300 and over 1 month.
So what would our next one be? What's our next coordinate on our graph? Right there. 2 and 2,400.
So do you see the pattern? What does the line look like? Can we draw the line at this point? Yeah, because how many points do we need? We really need 2, maybe 3 to make sure that it's still straight. Okay? But we can connect our line at this point. And every other coordinate on our table will fall on that line.
Alright. I tried really hard to make it straight.
And that's okay. If you're creating these lines and they're not perfectly straight, it's okay. As long as you have those coordinates represented, we're fine. So there's our graph.
Okay, so here we have our graph. We have Mrs. White in black, and then we also plotted Mr. Brown in green. So how are these graphs different than the trees that we did yesterday? How is this different?
One is going down faster than the other.
No, we're comparing to the trees from yesterday. Like remember we plotted like the diameter of the trees.
They're on the same graph.
Okay, so we did put these on the same graph yesterday. They were separate. What do you notice about the actual graphs themselves? They're going down.
Yeah, this one's going down. This one it's decreasing. Why is it decreasing?
Because you're paying for how?
Because every month you're paying $300. So what's happening to the amount that you owe?
You're subtracting from it.
It's decreasing, which is why our relationship is going down. What else do you see on the graph? Pull everything you see. Instead of us going question by question, tell us what you notice from the graph. What information can you pull about Mr. Brown and Mrs. White? Because our ultimate goal is to compare them. There's like, what, 5 things you could find at least?
What do we notice just by looking at this graph?
Giovanni, give us one thing.
This way pays more.
Mrs. White pays more money overall. How do we know she pays more money overall?
Because her initial value is 300.
Because her initial value is
3,000.
$3,000, and Mr. Brown's is what?
2,000.
Good. Okay, so one thing we do know, Mrs. White pays more money overall.
How
Because
much,
her car was more expensive.
how much more money does she pay?
Total.
Six.
Good. Her total difference is 600. What else do you see on the graph? So you've compared their initial values. Perfect. What else do we see?
They both, that both of the rate change
So their rates of change are the same. What does that mean in terms of this scenario?
they're both paying 300
They're paying the same amount every month. How do you see that on the graph? That they're paying the same amount? What is it about the lines that proves that they're paying the same amount?
If there were no numbers or coordinates and we knew nothing and we just saw these 2 lines, how can you tell what they're paying?
Because the points are plotted on the same line, but Mrs. White's goes a little bit more up.
So the lines are the exact same. They're the same slope. Like they almost look identical, except Mrs. White's is like a little bit higher up, but they're the same movement. So that's how graphically you could see that they're the same. What else do you see? So at this point, you've compared their initial values and their rates of change. Right? There's one more layer you can add to this because this is a real world scenario. What else do you see? Now they both bought cars, they're both paying off the cars. Their lines never connect. Okay, so that's actually a little bit more advanced. Why don't their lines ever connect?
Because we're both paying the same.
Because their slopes are the same, exactly. If you have 2 lines, and we'll go into this in our next unit. If you have 2 lines that have the same slope, but have a different y-intercept, they will never, ever, ever cross. It's not possible for them to cross. But looking just at the graph and understanding the situation, Mrs. White, Mr. Brown, they both bought cars, they're paying them off. What's the other piece of information that you can see from this? You saw the initial values, you compared their rates of change. There's one other layer, and this is the real world part. Look at the graph and look at what we haven't pointed out yet. What else do we see? In the context of the scenario.
They both end on the x-axis.
So both lines are going to end at the x-axis. What does the x-axis represent
0
in the scenario? In like the real world portion. Like what does the x-axis represent? Ramona.
months.
Okay, that's where so my months, but what about the months? What else? Because there's 2 values at that point, right? The x is the months, and what's the y?
How much they're paying each month.
Is that the y value? Is that what the y value represents? Because how much they're paying each month is your rate of change. But what's going on at the x-axis? Why are they both stopping there? What do you think?
They finished paying.
How do you know that they finished paying at the x-axis?
Because when you're on the x-axis, like on the y-axis, you know,
When you're at the x-axis, what's your value for y? Your value for y at the x-axis is 0. That coordinate,
So what is this coordinate right here?
0
This coordinate.
10, 0. The number of months is 10. The amount that you owe is 0. So that x-intercept, where your line crosses the x-axis here, represents what moment in time in terms of the scenario. What happened at that point on the graph? They finished paying their cars. So what do you notice? What do you notice? It takes Mrs. White longer. How do we know that it takes Mrs. White longer to pay her car off?
Because she stopped on the 10 and Mr. Brown, he stopped at the 8.
So
At
what is
8 months.
Oh, at 8 months. Good. So what does that mean?
Which means that she had
So what happened at 8 months? And what happened at 10 months?
to finish paying.
Yeah, it took Mr. Brown 8 months to pay off the car, and it took Mrs. White 10 months to pay off the car. So we know that Mr. Brown paid the car off faster.
And why did he pay it off faster? Did he pay it off faster because he paid more every month?
Because Mrs. Woods' initial value is higher.
Yes, they paid the same amount every month, and you noticed that right away. But her car was more expensive, so it took her 2 more months. Really good. That's like the next layer. So when you're comparing functions, initial value and rate of change are always there. But then you should be able to answer, and that is always a question. Who paid it off first? Who's driving at a faster rate? Who's going to get to a location faster? What would both of their amounts be after 6 months? Those are the next layer. That will be, you will be tested on that portion. Sorry, I can't talk. It's Friday. Perfect. Really great comparison. And the great thing is you didn't need to go through details. You just saw it, you pulled it out, and we're done. Well, I think we answered probably every one of these questions because you did a really great job just looking and pulling out the context.
Okay, so can we write an equation for Mrs. White's plan and Mr. Brown's plan?
This is y equals 3,000 minus 200.
3,000 minus 300. Are we good?
Oh, 3,000 minus. Up to 300.
Why is the x next to the 300?
She pays that automatically.
How often?
Which one?
Once.
She pays the 300 one.
She pays 3,000, it's 300, she pays every
Perfect. That monthly payment is what's affected by variable because our variable is what's changing. That 3,000 is what she's starting with, so we don't want that to be varied. Good.
So what about Mr. Brown's plan?
You can use the same format as Mrs. White's. Just use the values from Mr. Brown.
3,400
3,400 minus 300x. Okay. What if I wrote it like this? Is that the same thing?
No,
No,
you're
no,
adding.
But what's the sign of that 2,400? Like this right here. What kind of 2,400 is that? So are they the same? So that is how we represent it, but you don't have to. Most of you like to do it that way, the 3,000 minus the 2,400 minus. They're the same.
As long as you know, like when you write it this way, you know what the initial value is and you know what the rate of change is.
And that's where the context of the problems come into play. Because even if you accidentally wrote the equation wrong, you'd catch it if you understood. Like she didn't start with a debt of $300 and then pay $3,000 every month. And if you went through from that equation and tried to build a table, you would see that the values don't add up. Don't let the common sense part go. You understand the scenario, you can actually put it together mathematically much better.
Yeah, we're getting this ready. Okay. So we have a quiz. So the number one, there's a table here. You're gonna say, is this relation a function, and how do you know? So that's all you don't have to copy it on the table, just answer it, is it relation a function, yes or no, how do you know? Number two, there's two companies' rates for textbook rentals, because like when you get to college and stuff, you can like, instead of buying textbooks, you can just rent it for the semester. So there's two companies' rates for textbook rentals. What is the initial value and the rate of change for each function? And what is the cost to rent a textbook for 4 months? So there's two different questions there. Actually, there's really three. You're finding the initial value and the rate of change for each function, and then you're going to find what it costs to rent a textbook for 4 months from each company. Okay, so we're comparing these two functions. We have company A, C equals 15M plus 10, and then we have company B, it's $19 per month per textbook and $6 registration fee.
So this is not what you are doing today, right? Because we worked on decreasing scenarios. This is more what you did yesterday. So think back to yesterday's DOL, think back to yesterday's lesson with the trees, right? And then the first is really a recap of earlier in the week. Is it a function? Okay. So you can use your DOL sheet from yesterday, or you can use a new sheet. Yep.
What's the deal?
What?
What's the deal?
Can you
That's a quiz.
It's a
Oh,
It's a quiz, but you can either put it on the DOL sheet from yesterday or